So welcome. We're here to talk about dragons and technical debt. So my name is Ernesto, and you can find me on Twitter, GitHub, anywhere with the handle Tagwerker. My pronouns are he, him, and I'm originally from Argentina. So for the next 3 weeks, you might see me like this, watching football, or like you call it, soccer. I live in Philadelphia. Philly? Yeah, all right, we have some people from Philly, great. So I love that town. I'm one of the organizers of the Philly Ruby meetup, and of course we love the birds. We love the Eagles too. And table tennis. Another thing that we love, or I love, is open source and Ruby. I wouldn't be here today speaking if it wasn't thanks to the work of so many other people that just published their code. And when I'm pairing with my daughter, basically she's the driver. I'm the navigator, and she's the one committing all those changes to the libraries that I maintain. So a quick thanks to my sponsors. My wife, Claire, my son, Teo, and my daughter, Luli. I wouldn't be here today if it wasn't thanks to them and their support. And when I'm not spending time with them, I like to work at my company, which is called Ombu Labs. We work a lot with Ruby, Rails, JavaScript, and open source projects. A few years ago, we launched a productized service called fastruby.io. And we focus on helping companies upgrade to Ruby and Rails, more recent versions of Ruby and Rails. And a lot of the tools that I'm going to talk about today, we actually use them on a weekly basis to assess whether we're going to work on a project or not. Because not all applications are ready to, get a team to work on an upgrade for them. This gave me the opportunity to work a little bit on open source every week. So I co-maintain RubyCritic, Skunk, Bundler Leak, and Next Rails. So I want to talk a little bit about Here Be Dragons, because I know that a lot of people here might be like, what is that? Is that a game? Is that just a meme? Well, no, there's actually a story behind this. If you look, you might have heard of this phrase like hic sunt dracones, which is Latin for here be dragons. And the story goes like this. In the 16th century, cartographers would draw maps and would place labels in their maps that said, here be dragons. And sometimes they would just draw monsters in those maps that look like this. And I thought it was fascinating for someone to draw a map and then say, you know what, I haven't been to this part of the world, so you gotta be careful. There may be monsters there. And I love this story, but the story is not true. There are no maps out there that say, here be dragons. There is a globe called the Hunt Lennox globe that actually does have this phrase in it. And if you're ever in New York, you can go to the public library and see it, and it'll be there. And if you don't have the chance to go there, you can actually find it online. There's a 3D model that you can just play around with and see the phrase there in the middle. Okay, so enough about maps, right? Let's bring it back to code. What if there was a map to your code base? What if you joined a team and instead of just asking around about the thorny issues in the code base, you could just look at the map and see all these labels? What if you could turn this phrase into this one? Be careful with this part of the code base. Nobody wants to touch it. There's a lot of tech debt. So how do you find these dragons in your code base? How do you find tech debt in your code base? Well, sometimes it might be obvious. It might be just like staring at you. And you might ignore it, but it's there. So yeah, of course we're going to talk about tech debt and dragons as the same thing. And I'm going to talk about 4 different dragons. The first one is the complexity dragon. Then we have the smelly dragon. Then we have the shape-shifting dragon. And finally, the untested dragon. All right, so let's start with the first one. I might ask you, where's the tech debt in your code base? And you'll just say, well, just find the most complex files. And I'm like, okay, I'll open one of those files, and it'll be just a mess. Like, I look at this, and I don't even know where to begin. Like, do I just run? Do I chop one of those guys' heads off? I don't know. And how do I stop using my gut to say, like, yeah, there's tech debt here, and I start using a tool that's measurable? Well, we can look at this example. We have this file that basically has a method called yay. It does computation, and then it checks for a condition, and it outputs something, or it doesn't. So we can use a tool called Flog. And Flog, in its definition, reports the most tortured code. And you can just gem install it and run it on any of your files. And you'll get a Flog points score. You can think about it as a complexity points score. And what does it mean? Like, I have no idea what it means. So let's dive a little deeper. So for every single operation and every single statement in your code base, it's going to assign a numeric value. So an assignment is worth 1.2, an eval is worth 6.0, and so on. So for every single operation, Flog defines a score for it. Now, this is not super important, but if you want to check out the source code, you can see the scores over there. Now, Flog won't report things like code smells or duplicated code. It won't even tell you if the code is constantly changing. That's when the smelly dragon comes in. You might say, like, well, find the file with the most code smells. And you open that file, and it's like, whoa, this stinks. It smells so bad. There are a ton of code smells. And code smells are indicators of where your code might be hard to read, maintain, or evolve. Now, they're not necessarily wrong, okay? To have a good code base, a tech debt-free code base, doesn't mean you have to like solve every single code smell in your code base. And I'll give you an example for this. Duplicated code is a code smell. At the same time, Sandy Metz says something about this. Duplication is far cheaper than the wrong abstraction. So you might want to solve the code smell, fix it, but then you might come up with the wrong abstraction and it'll just make it worse. It's not actually making it better. In order to find the code smells, we can use a tool called Reek. And Reek is super helpful because it has a crowdsourced database of code smells. And you can find them all in the library. And if you open any of those files, it has an explanation of what the code smell is. And of course, there is a file in the library that describes the particular code smell. And every single one of these files defines a sniff method. Now, Kevin, right before me, gave a really good talk on static code analysis and parsers and all that. So Reek uses a Ruby parser to actually read the code base and try to sniff the patterns that are code smells. So we're going to try to find the code smells in this particular file. You're like, okay, does it even have smells? It's like, yeah, even such a small file has 2 code smells, and we can find them by just running Reek on it. And it will tell me that there is an irresponsible module because it doesn't have any documentation or comments. And it will tell me that the variable A doesn't communicate anything, which, they're valid points. So I look at the code and I say, okay, I can just rename the variable to say something. I say, okay, Let's call it eval result. Slightly better. I run Reek again, and cool, it goes away. Awesome. So let's move on to the next one. That one is about comments. And when I look at this file, I see that there are no comments about the module foo. Now, to be honest, my team doesn't really believe in comments. We lean more on tests and the test suite to document our code. So I don't really want to add a comment here. I don't really like Reek's default configuration. And that's okay. I can just go in and change the configuration to ignore this particular code smell. I run Reek, and everything's good. All right. Now, Reek is not going to report whether the files are constantly changing or if the file is super complex. So that's when the shape-shifting dragon comes in. You might think you know a file, and you might think you know what the file looks like one day, but 2 weeks go by, and the file changed completely. So we're talking about churn here. Files that keep changing over and over again because requirements keep changing over and over again. So we can use this very cool tool called Git. You can just do git log, and then we'll know that that file has a churn count of 3. Now, if we're not using Git, that can happen, okay. We might want to use churn, the Ruby gem by Dan Mayer. Now, churn has support for 3 different source code management systems, like Mercurial and SVN on top of Git. And it has a couple more things that are like syntactic sugar to the question of churn. So if you run it on Minitest, you can find the churn for the last 12 years of all the Ruby files in the project. And you might think, like, what do I even do with this information? So, to be honest, by itself, it adds very little value. But it's super useful when you start combining it with other metrics. So how can we bring it all together? Complexity, code smells, and churn. Well, RubyCritic can help us with that. And I like to think about RubyCritic as cartography for Rubyists. You can install it, and then you can run it like this. And it will generate an HTML report that looks like this. And that's a lot of information, right? So you're like, what do I do with this? Like, does this help me in any way? Well, yes. Let's dive a little deeper. On the left side, you have the GPA pie graph. So every single file in the application gets a GPA score. It's also the cost. So I'll use cost and GPA score interchangeably. And if you're not familiar with the GPA score, basically it goes from A to F, A being 100% and F being 0%. So the main idea behind this is that costly files are hard to understand, and they're also hard to maintain. Cool. So if you want to see the formula RubyCritic uses, is pretty simple. Combines code smells and complexity from these 2 different tools. And the method definition is very quickly, very clear. Give me the cost for all the smells, add them up, and then add the complexity divided by a magical value. Can't explain the magical value, but basically you get a score, and then that translates into a GPA score. Now on the right side, you have the churn versus complexity graph. And this is where things get super interesting, because this combines churn and complexity. So if the user file changed 2 times, the complexity is 100,000 Flog points, you're going to see the file up there to the left. If a count has changed 27 times and the Flog points are 100, you're going to see it down there. So for every single file in your code base, you're going to see them plotted in this graph. And it is useful to divide the graph in 4 different sections. The lower left section is where you want to be. You want the files to be low churn, low complexity, because you can quickly grasp what they're doing, and they're not changing that much. In the upper left section, you're going to find files that nobody understands, but it doesn't really matter because they're not changing. And I like what Sandy Metz has to say. If the code never changes, it's not costing you money. So it's not your priority. Now, in the lower right section, you have files that are very easy to understand, but they keep changing because of reasons. It could be a configuration file, a version file. It doesn't really matter because they're easy to understand. You open them, it's like straightforward. All right, so the next section is where we want to focus on. All right, these files are complex and change a lot. And I like what Michael Feather says about this. He says, sometimes a class becomes so complex that refactoring seems too difficult. So when do you refactor it? Later. But later never comes. Because later, you leave your job and it's someone else's problem. You might try to refactor it, you start, but then you find that there are a lot of problems and you just give up. So when you find a project that has a graph that looks like this, you know you're in trouble. You know that you're going to get asked to ship a change on a Friday. You know that the test suite doesn't work very well. And you're going to ship it, and this is what's going to happen. You're basically going to spend the entire weekend firefighting. And that's not okay. So that's when the fourth dragon comes into play, the untested dragon. Now, this particular dragon is scary because nobody has challenged it. Nobody has tested it in years. So we don't know how it's going to behave. The good news is that we can use a tool called SimpleCov to calculate code coverage. We add it to our gem file like this, and then we can load SimpleCov right before we load all the test files. And of course, we want to surround it with an environment variable so it doesn't run every time. And then you run it like this, and it will generate an HTML report with a list of all the files and their code coverage. Now, SimpleCov doesn't tell you whether the test suite is good or bad, whether your test cases have the right assertions or not. It does tell you whether your file's code gets exercised by your test suite. So that's one thing to consider, still very important information. If you're using RubyCritic with SimpleCov, you can actually find a section with a GPA score that's based on the code coverage percentage. All right, so we went through the four dragons. We saw 4 different tools that you can use to find these dragons. Now let's bring it down to like an example. The sprint just started and you have some time to refactor a user or account. Which one do you pick? Well, you start using the tools and you find that user has a tech debt score of 1,000. You see that account, surprisingly, has the same amount of tech debt score. You look at them side by side and you might be tempted to say, user and account have the same amount of tech debt. Do they? You don't know, because you don't know what the tests look like for those files. What if I told you that user has no tests? We managed to build an app with no tests for the user class. And then account has a really good test suite that covers about 90% of its code. We look at them side by side, and which one are you going to refactor today? User? Okay. You're bold if you said user. I would not refactor user because I don't know if it's going to break while I'm doing it. So I would pick account because at least I know that I'm probably not going to introduce a regression while refactoring that file. So yes, I guess I just want to avoid fires, and I want to avoid the class with the most technical debt. I'm lazy, okay? All right, so let's combine code smells and complexity and code coverage. I like to also think about this as the vital signs of your application. You can think about it as signals for your code base. Cost is one of them, and we just said cost is basically code smells and complexity. And then you have code coverage. But what if we could calculate a new signal that combines both of them? And I like to call that the Skunk score. The Skunk score is a function of cost and code coverage. And the main idea behind this is that files which lack tests are harder to maintain because you don't know if you're going to be breaking them as you go shipping features or patching bugs. The good news is that there's a gem for this. It's called Skunk, and you can install it like this and then run it like this. Unfortunately, it won't generate a nice looking HTML report yet, but it will generate this table in the console. And the main idea is that at the very top, you're going to have files that are very costly and have very little code coverage. So you might want to consider these files when you're about to refactor them. And the formula is pretty straightforward. The Skunk score is RubyCritic's cost if there is perfect code coverage. If there isn't perfect code coverage, there's a penalty factor. So if there's 90% code coverage, the penalty factor is going to be 10. And that's going to be applied to the cost that we talked about. All right, so now we can finally draw the map. Okay, we have the tools, we can look at the code base, and we can run them, and we can draw a map that looks like this. No, that's a lie. I hope so. Someday we'll draw the map that looks like this. But for now, the map looks like this. Looks like the churn versus complexity graph. And it looks like the upper right section. Or it looks like this, like a table in your console that's telling you, these are the most complex files with the least amount of code coverage. All right, so now that we know where we are, we can pick a direction to go in the right way. Unfortunately, this talk does not include a silver bullet. There's just like no silver bullet, but there are a few ideas that we can use to slay these dragons. Yeah, this guy's awesome. All right. So the very first one is to define what's a dragon. And this is the whole concept of stop making it a gut feeling and start making it a measurable metric. And to define the dragon, you need to talk to your team. What is technical debt to your team? Do you favor more tests than comments in your code base? Well, that's a very personal decision for your team to have a discussion and agree that this is technical debt in your project. And once you find the definition, when you can all agree on it, you can find the toolkit and configure it to apply it to your PRs and your changes. So then you can draw the map and place the Here Be Dragons labels, and you can pick your battles based on metrics. So instead of saying, I paid off a ton of technical debt with these changes, you can just say like, I reduced the Skunk score for this file by 20%. When it comes to slaying the untested dragon, one way to go about this is to look at the Skunk table and pick the files at the very top. If you write more tests, good tests for these files, the Skunk score is going to go down, so the files are going to go down in the list. If you don't want to use Skunk, it's fine. You can use SimpleCov and RubyCritic and pick the files at the very top. To slay this smelly dragon, I see at least 2 different ways to go about this. One is to pick a file and get rid of most of the code smells that make sense to your team. The other way to go about this is to pick one code smell and focus on that code smell throughout your code base. So you start to turn your files into better smelling dragons. Now the hardest part is the last one. How do you go about slaying the complexity dragon? Well, you can think about this particular dragon as like a file that has multiple responsibilities and they all want to burn you. So what you can do is try to break down that file into smaller files and basically, divide and conquer. So you can break this file and it might start looking like this. And then it's more manageable. All right, so we talked a little bit about these 6 different Ruby gems that are out there. They're open source and you can use today if you want to. Of course, there are a lot more Ruby gems out there. There are paid services that you can use. And I don't really care what tool you use, but I think it's important that you pick some of these tools to talk about technical debt with your team. And if you leave this talk with 3 ideas, I hope they are these ideas. First is pick your dragons. Pick the things that mean technical debt to you and your team. Then pick your toolkit. As I mentioned, there are so many Ruby gems out there that you can use, and you can basically codify your tech debt definition and make it executable. And I would advise you to not go with the default configuration for all these tools. Like, there are a lot of things that RubyConf, Reek, and all these other tools tell you should do, but you can disagree. You can configure them to match your definition so it's easier to get buy-in from all your team. And finally, you can start slaying your dragons in a gradual and measurable way. So it starts to be more of a metric-driven approach and less of a gut-driven approach. All right, thank you very much.